Hello everyone, this is Pawan and today I'll be talking on the data source architectural patterns. So this is going to be a brief overview of the presentation today. We'll start off with a getting a brief notion of data persistence, uh, then move on to what exactly is data source architectural patterns, like a brief introduction of that, and then maybe talk about the different data source architectural patterns and and conclude with a summary of the key points that we discussed and list a couple of references that we used in making this presentation. Um, so let's start with getting sort of like a brief notion of data persistence. So we did talk in detail in the class about data persistence. So when we work with applications, when we design or work with applications that has a lot of data moving around between the objects, we would need some methodologies of saving and retrieving this data so that we can use it at some point in the future. And so what we are ideally looking at is a notion of persistence. We want the data to outlive its creator, and we did look at several methodologies to achieve this. So the brief idea is like you want to save the data to either a file or a database so that it can be used later. And the approaches that we kind of considered or looked at was the first one was the cool homebrew file formats, where what we would do is let's say we are interested in saving the data of a certain class. So we would write a bunch of methods for saving or loading each class that we are interested in to a file, and we would make the class implement this save and load methods. Uh, so this is sort of like similar to the the savable interface that was discussed in the class, and the savable interface had these methods like load yourself and save yourself, and the class that we want to kind of wanted to save would implement these methods, and we would be able to save the data of this class to a file. Okay, so that was one thing. So that was one approach. The second one was a bit cooler one. Okay, that was the notion of serialization, where we would convert the state of an object into a byte stream. So we didn't have the hassles of creating this interface called savable and writing these methods like save yourself and load yourself. Um, so we would make use of this file streams, like the file input streams and the file output streams, to sort of like save and retrieve the data from the file. And an advantage of this was, so let's say you had a parent class which implements the serializable, and let's say you had a child class that sort of extended to sort of like derive itself from this parent class. We didn't want so the child class didn't have to implement the serializable. It could just reap the benefits of the parent class implementing the serializable, and it was much cleaner in the way you handle the part of saving and retrieving the data. So and the yeah, but these two were primarily dealing with the files, like you were using the files to actually save and retrieve the data. Okay, so we also looked at the notion of database, and we specifically looked at the Spring and the Hibernate portion of it, and we also did an extra credit on that. Uh, so looking at the Hibernate part of the object relational database, so what we did was so we used annotations that were part of the Hibernate, okay, to designate the class that we want to table by using this annotation at the rate entity, and we sort of created this session factory and marked the classes that we want to save as mappings in the Hibernate uh, configuration XML file. And so we used this session factories to sort of like open a session, begin a transaction, maybe insert something into the database, or update something into the database, or delete something, or find something from the database. Okay, and we used to have this hibernate layer in between the model layer and the database layer, which where all the magic used to happen. And so we didn't have to have this SQL queries written in our model layer. So all we did was call the methods that were exposed in the hibernate layer in the model layer, and the hibernate layer would actually do all the job for us to save into the database or retrieve from the database. So yeah, so we did look at this quite a few notion of data persistence in class. So data source architectural patterns is another way of looking at solving this problem of where you have an object-oriented program that needs to interact with a relational database, and we are trying to look at how these data source patterns can be used to manage the interaction between your object-oriented classes and a relational database. And in particular, we'll be looking at four of them. So the table data gateway, trolley data gateway, active record, and the data mapper. So let's start. So let's start with the table data gateway. So the table data gateway, what the table data gateway offers is sort of like a wrapper class between your uh, object-oriented class and the database. Okay, and this wrapper class is going to have like simple interface methods like the database access methods like the insert or the delete or the update or the find methods, okay, that consists of all the SQL queries that consists of all the SQL methods to sort of like access the database and maybe save and retrieve the data. So it's called a table data gateway because we have this wrapper class that is focusing on just one table that is stored in the database. And this wrapper class holds all the SQL that is required for accessing this single table in the database. And typically, we have just uh, one table gateway per table that is stored in the database. Okay, and and this aims at decoupling the SQL from the business objects to simplify a lot of things. So what we're looking at is a layer in between your model layer, in between your class and the database, okay, which is going to contain all the access methods to sort of like interact with the database, and all the class has to do is all the class has to do is call the methods that are part of this wrapper class to actually interact with the database and not have any of the SQL uh, inside the application that we are working on it. So we can have the application which just calls the methods of the wrapper class and does not have to worry about all the integrated details of how the SQL query is done, how the entry is actually inserted into the database, or how the data is actually retrieved from the database. So it can forget about all of this and just concentrate on getting the object orientedness of the application. So to look at to demonstrate with an example, so let's say we have this table. This is your person table that is currently stored in the database. So we have two rows identifying the information of two different person and the department they are in and their salary information. Okay, so this is going to be your caller class, like the application that we did talk about. And so because we are working with this person class that is stored as a table in the database, so we would be having a person gateway, the wrapper class that we talked about, and that is going to have all the methods. Okay, so if you want to find a if you want to find an entry in the database, you just pass in the ID, and the database is actually going to return a record set to this person gateway, and the gateway is actually going to give back the information to the application in the way it wants it to use. And let's say if the application wants to uh, update a row in the table, it just calls the update method in the person gateway with the updated information, and the gateway is actually going to run the appropriate SQL uh, to update the entry in the database. So what we are essentially looking at is sort of like a wrapper class between your application and the database, which sort of like abstracts and sort of like has all the database access method, and is going to provide you a very simple interface to interact with the database. So moving on to the raw data gateway. The raw data gateway is sort of like similar in structure to a table data gateway, but instead of having a wrapper class for the entire table, for one entire table in the database, we have objects. We have a raw data object for each row in the table. So if you have like one table with like 5 rows, we have 5 different raw data objects that is offered to, that is given to the application to work with. Okay, so yeah. So it's going to be an object with the exact with the exact structure of a single record in the table. And so if you look at the raw data object, okay, so the raw data object, each database column in the raw data object becomes a field in the raw data object, and the object is going to contain the database access methods like insert or update or delete. Okay, and each is going to have the required SQL. So if you want to update a certain row in the table, so what you do is you get the object of that row, you request for the object of that row, you pass in the updated information to that object and call the insert method, and the row is going to be updated in the table. And one interesting thing about this is you're going to have all the find methods where all the SQL queries happen. Okay, so these find methods are going to be held in a separate finder class. So, and yeah, and typically that's going to be like one row data gateway object per row in the table. So like I said before, if we have like a table with 3 rows, you're going to have, sorry, we're going to have 3 raw data gateway objects. And let's say you have another table with like 5. Okay, so we're going to have 5 raw data gateway objects for that table. So yeah, I know the problem is like you're going to end up in a lot of rows, but yeah, but the sort of like abstraction that is offered is actually good. So to look at the demonstration, so what's going to happen is like let's say we have the client code here, and the client code wants to maybe sort of like update a table, so update a row in the table, or maybe like insert a new, like update a row in the table. Okay, so what's going to happen is like the client object, so the client the application is actually going to start by creating a new person finder. Okay, so remember we said that the find methods are held in a separate finder class. So before the client can actually go ahead and update maybe some information of a certain row in the table, so it has to it has to create a new finder class. Okay, so it's going to create a new person finder to work with the person class that is currently stored in the database. So it's going to invoke the find method of this finder class with the ID as 1. Let's say we want to access the first row of the table, so we pass in this ID field as 1. Okay, so once you invoke the find method is going to run the SQL query, the select query with ID information as 1 into the database, and the database is actually going to return us a record set. Okay, and once the record set is created, the finder class is going to create the raw data objects for this particular row, and that object is actually going to be returned back to the client so that the client can actually work with this object. Okay, so like I said before, like this is pretty much in the exact structure as out of the table data gateway, but instead of having like a wrapper class for one complete table, we have objects for each row so that the client can actually work with these objects to make the required changes. Um, Moving ahead, going to the active record. So active record is going to be quite similar again to the raw data gateway, wherein you have this notion of the finder class in between your client code and your database, and you sort of create a raw data object for each row in the table uh, in the table in the database for the client to work with. Okay, but in addition to this logic of the raw data gateway, we also have some additional domain logic. Okay, we could have some domain logic methods that could be added to this active record object that we create. So 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 quite similar to the raw data gateway, the active record object is also going to contain the insert, the delete, and the update methods, which are the database access methods, each with the required SQL to sort of like interact with the database. But in addition, it's also going to have some domain logic methods. So for example, if you want to maybe insert a value into the database or update a field in the database with a new value. Okay, so you could have a domain logic method like validating the data that you're trying to put in so that it meets some business requirements or something like that. Okay, so in addition to having this database access methods, you're also having this uh, domain logic methods to maybe validate or maybe check for exceptions or like having adding some exemptions or something like that. Okay, and like the raw data gateway, we are also going to have one active record per table in the database, per row in the table in the database. We're going to have an active record object, and objects are typically these are called so these are called active records because objects are typically represented as a record on the table in the relational database. And another interesting thing is, so each active record, like I said before, each active record is going to contain both the database access methods and the domain logic in place, and each active record is going to be responsible for saving and loading the data to the database, and also for any sort of the domain logic that acts on the data. So if you look at the demonstration of this, so we have this person class, sorry, we have this person table that is currently stored in the database. And if you look at this is going to be the person activation record that is sort of created for each of the row of the table in the database. So we're going to have the database access methods, which are going to be like maybe like insert or update or delete or find methods. Okay, but in addition to that, also going to have some domain logic methods like validating whether the data that you want to insert into the database is meeting the business requirements, or maybe getting in the exemptions or putting in some exemptions, or like, yeah. So, and what the caller does is in fact access the methods that are exposed in this. The caller uses this person activation, like, this active record object to sort of like interact with the database. And if the caller wants to update maybe this the first row, it's gonna request for this it's going to request for the object of this row, put in the updated information, and just call the insert method or the update method, the update method in this case, sorry, to update the information of this, maybe the first row. So yeah, it's going to be pretty similar to the raw data gateway plus, but with an addition of some domain logic. So sort of like, validate some things, or maybe get some exemptions or something like that. And the final one we will be looking at is the data mapper. Okay, so data mapper, the notion here is you're going to have sort of like yeah. So if you look at the data mapper, like if you move on to an example rather than looking at the description before, so so this is the person object that maybe a client will be working with, and this is the database which we will be interacting with to sort of like save this table and retrieve it back. So what the data mapper achieves is it has a layer in between the object, the person object, and the actual database. Okay, which and layer, this layer is going to have a data layer. It's going to have a data mapper layer, which is going to have a layer of mappers, and this is responsible for performing a bidirectional transfer of data between the objects and the database, and it is also going to keep this layer, the object layer, independent of the database layer. uh, yeah, independent of the database layer. So yeah, so if you look at it, a data mapper is basically you're going to have like a data access layer that performs the bidirectional transfer of data between the relational database and the object. And the goal that the data mapper is trying to achieve is move the objects between move the data between the objects and the database while keeping them independent of each other and the data mapper itself. Okay, and another advantage is another advantage is so with the data mapper, the in-memory objects need not have any knowledge of the database, like whether like what kind of database is present, like how the database is sort of like yeah, that's sort of like this thing, a given fact that so when we try to achieve this notion of abstraction, we are really not worried about how the layer in between your the objects and like the class, the client and the database is actually storing and retrieving the data into the database. So yeah, with the data mapper, the in-memory objects need not have any knowledge of the database. So yeah, so like I said before, we're going to have this person mapper class sitting in between this person object and the database, and this is responsible for doing a transfer of data from the yeah. So if the client if the client code has a data. So if the client code wants to update a particular row of this table in the database, so he's going to have this person object. He's going to update the relevant fields, maybe like the name or the department or the salary. These are the fields of this person class in the database. So when he wants to update a certain field, so he's going to get the object, update the fields of that object, and he's just going to call the update method, and the update method is internally going to make use of this person mapper to move the data that the client now updated, so that it can be saved or it can be updated in the database as well. So yeah, so what we're trying to like what we have is like a sort of like a data access layer, a data access layer that performs the bidirectional transfer of data between the relational database and the object. So yeah, in conclusion, we did look at the briefly at the notion of data persistence and why we need data persistence, why we want to save the data to maybe a file or a relational database, and the different approaches that we kind of encountered, like we talked about in the class, and also the data source architectural patterns that can be employed to sort of have this notion of data persistence, and how the data source architectural patterns describe the paradigm of interaction between the objects and the relational database. So yeah, so each of the patterns, each of the design patterns, the data source architectural design patterns that we discussed had uh, it's had like its own way, like not exactly its own independent way of implementing things or achieving or giving this notion of abstraction to database access, but yeah, so it was like a slight modification, or like maybe uh, so in the table data gateway, we had the entire table given to us as so handled by one wrapper class, and that wrapper class would have all the SQL methods. And going from the table to the row, okay, instead of having an object, instead of having a wrapper class for the entire table, we had objects for each row. And from raw data gateway to the active record. So the active record added this notion of the domain logic in addition to creating an object for each row. And the data mapper had this data access layer that kind of handled the transfer of the data. So each design pattern kind of provided an abstraction to the database access, so that the application's interaction with the database is sort of like simplified, and the application didn't have to worry about writing all the SQL uh, to maybe insert or update or find, and focus on the object orientedness of the application. And it's also that when you mix SQL in your applications and you don't do it in the right way, it can lead to more problems. So it's always better to have like sort of like a layer in between your application and the database, which handles all the interaction with the database for us, so that we can focus on something good that we want to do. So yeah, these were like a couple of references used. So yeah, thanks.